Hey everyone, and welcome. Today, we are taking a deep dive into the official blueprint for the intelligent infrastructure that's going to power our autonomous future. And no, this isn't some far-off science fiction. This is a real, detailed, strategic plan for the roads of tomorrow.
So, to kick things off, let's start with a really simple question. Picture this, a self-driving car in the middle of a blizzard. How is it supposed to see when its cameras are totally blinded by snow or its sensors are getting confused by heavy rain and fog? The truth is, even the most advanced tech you can pack into a car has its limits.
And the answer to that question is, well, the car's own systems are really only half the story. For true all-weather, all-condition autonomy, the car just can't do it alone. It has to be plugged into something way, way bigger.
Yeah, you heard that right. The car needs to have a literal conversation with the road, with the traffic lights, with all the infrastructure around it. And today, we're going to break down the exact technology that makes that conversation possible.
Okay, let's get into it. And to really understand this whole plan, we're going to do what the best consultants do. We're going to start with the end goal. This is the official vision for what our world is supposed to look like by the year 2040.
Now, I know that sounds like a mouthful of corporate speak, but the key phrase in there is tightly coupled. See, this vision isn't just about cars driving themselves. It's about creating this living, breathing digital ecosystem where the vehicles, the maps, and the city itself are in constant communication. They form a closed loop that makes everything work together, making it all safer and way more efficient.
So how on earth do you build something like that? Well, the whole vision really rests on two absolutely foundational pillars: incredibly detailed autonomous driving maps and ultra-precise positioning technology. Let's break down each one.
First up, the maps. And I mean, seriously, forget about the little navigation app you've got on your phone. These are hyper-detailed, machine-readable blueprints of the road. They don't just show you where to turn, they tell the car's computer the exact width of a lane, the height of a curb, even the location of every single traffic sign.
And second, positioning. I mean, for a car to use that ridiculously detailed map, it has to know exactly where it is. We're not talking about the meter-level accuracy from your phone's GPS. We're talking about centimeter level. That's the difference between being safely in the middle of your lane or drifting onto the line. It's that critical.
All right, so let's dig a little deeper into that first pillar, the smart map. How are these unbelievably complex digital worlds actually built? This chart really shows you the whole evolution. We started with our standard navigation maps, which were accurate to maybe 5 or 10 meters. Then we got ADAS maps, that's for stuff like lane keep assist, and that got us down to about 1 meter of accuracy. But for full self-driving, we need these high-definition or HD maps that are accurate to just 20 centimeters. That is a mind-blowing leap in precision.
I want you to think of an HD map kind of like a digital lasagna. Seriously, the bottom layer is your basic road network. Then, on top of that, you add a layer with all the precise lane markings. Then you add another layer with every single traffic light and sign. And then the final, and maybe most important layer, a dynamic one that's constantly updated with real-time info like traffic jams, accidents, or construction ahead. But you can imagine creating and constantly updating these maps for every single road is just astronomically expensive. It takes whole fleets of special vehicles and massive data centers. So a really clever strategic shift is happening called light maps with heavy perception. Basically, the car gets a simpler base map from the cloud and then uses its own powerful onboard sensors to fill in the rest of the details in real time. It's a fantastic way to balance cost and accuracy.
Okay, on to our second pillar. You've got the perfect map, but it's pretty much useless if you don't know your exact location on it, right? This is where that pinpoint accurate positioning comes into play.
And this doesn't come from just one piece of tech. It's a team effort. First, you've got your Global Navigation Satellite System, or GNSS. Think of it like GPS on steroids. That tells the car its general spot on the planet. But what happens when you go into a tunnel? Well, that's when the Inertial Measurement Unit, or IMU, takes over. It uses gyroscopes and accelerometers to feel its own movement, basically saying, okay, from our last known point, we just moved 10 centimeters forward and turned 2 degrees left. They work together to give you a constant, uninterrupted position.
And what's really fascinating here is the global scale of this. It's not just one system. To get the reliability you need for safety, these cars are going to be pulling data from 4 major satellite constellations all at once: China's Baidu, America's GPS, Russia's GLONASS, and Europe's Galileo. Using all 4 gives you the redundancy you absolutely have to have for a system this critical.
So here's the bottom line.
The crucial point is this. Whether we're talking about the map data or the positioning tech, everything, and I mean everything, is driving towards this one target: centimeter-level accuracy. It is the absolute, non-negotiable requirement for a system we're going to trust with our lives at highway speeds. So we get the vision, and we get the two pillars that hold it up. Now let's look at the actual roadmap, the concrete step-by-step plan for turning this vision into our reality over the next couple of decades.
And the rollout is, well, it's methodical, but it's also incredibly ambitious. The plan starts by focusing on major cities, aiming to have full HD map coverage and centimeter-level positioning there by 2030. Then it expands fast. By 2035, the goal is to cover all Tier 1 and Tier 2 cities and have that super accurate positioning available nationwide. And then the final piece of the puzzle clicks into place by 2040, with complete HD map coverage of every public road and a truly global real-time positioning service.
You know, when you put all these pieces together, the maps, the positioning, the timeline, you start to realize that this is about so much more than just transportation. What we're really talking about is building a digital nervous system for our entire physical world.
So why does all of this matter to you? The impact is going to be huge. First, and most importantly, safety. This system gives vehicles a kind of superhuman perception that can see right through snow and fog. Second, efficiency. When every car knows what every other car is planning to do, they can coordinate to basically eliminate traffic jams. And finally, this is the bedrock for truly smart cities. We're creating a real-time digital twin of our road network, and that is going to unlock services and possibilities we probably can't even imagine yet.
And that brings us to our final thought for today. This roadmap, it's not just a bunch of technical specs. It's about giving our infrastructure senses and a voice. And it leaves us with a pretty provocative question. When our roads can finally see, think, and talk, what are they going to tell us?